I'm here to want to talk to you about Flight Opportunity Program, how to get started, and what a lesson we learned along the way, and hopefully share with you how we look forward to the futures. Okay. By the way, I want to thank Pat Hines for inviting me to this conference. It's my first time at a conference, and I'm very impressed with this conference. I hope to come back again. Yeah. Let's see. Here we go. So the origin of the Flight Opportunity Program start out, I'll just bring everybody back in. Several speakers have mentioned the 2004 Ansari X Prize. I think all of us are old enough to remember those days. Those were exciting days. And follow on, there was Northrop Grumman's Lunar Lander Challenge. Armadillo Aerospace had won the first prize out here in Las Cruces International Airport. And later on, Masson had won it also. So at about the same time, and I want to shout out to Dan Rasky, my next speaker. He's the founder of Space Portal at NASA Ames. And a credit to him, and he and his people started out with the Commercial Reusable Suborbital Research Workshop, a cruiser, so to speak. And if you notice, it says Human Tender Suborbital Science Workshop. So there's still hope. The Flight Opportunity Program is not just about payload, but it's also about human tender flight. There's more coming in later charts. So the long story short, in 2009, they finished a report to National Research Council. In 2010, President Obama signed the NASA Authorization Act of 2010, including a section called 907, Detailed Provision of Cruiser Program. In October 2010, they combined Cruiser with another similar commercial parabolic flight called FAST program, become Flight Opportunity Program. At a time when the news was announced to establish a Flight Opportunity Program, everybody expected this program to be selected, situated at Ames. So I remember John Kelly, the first program manager, told me when he heard on the news that on TV they're going to have this program at Armstrong, he was shocked. He called his counterpart at Ames right away and said, "Did you hear what they say?" He said, "Yeah, I don't know what's going on." So long story short, that's how the Flight Opportunity Program situated at Armstrong. And it started with, prior to STMD, it started with OCT. So we move forward. So what is Flight Opportunity Program? So I give you the STMD mission goal: develop cross-cutting technology for future human and robotic space exploration, as well as simulate growth in U.S. aerospace industry, new revolutionary technological capability to create, expand market, product, and services. So Flight Opportunity the goal is to mature exploration of high-priority space technology through flight demonstration in relevant environments, and develop enabling technology to accelerate to market affordable suborbital and small satellite launch capabilities. So in essence, the Flight Opportunity Program enables low-cost access to the spaceflight environment for students, researchers, and technologists on commercial low-gravity simulating aircraft. That's a zero-G aircraft, high-altitude balloon, and reusable suborbital sounding rocket. By the way, that highlighted text, it was direct plagiarism from Eric Stomer's CSF news release. I like it so much, so I copy and paste them. Thank you, Eric. So the Flight Opportunity is enable the flight test platform for lower level technology to mature. You fly, you get data, you get the feedback, and you maybe improve. And we'll see later on the chart, some of the technologies start out with basic zero-G flight and now are ready to go to space station for flight experiments. So at NASA, we categorize technology level under TRL, technology readiness level. And TRL 1 is, hey, I got a great idea and satisfy law of physics, to all the way to TRL 9 is actually being flown, demonstrated in space, or the relevant environments. The problem is the value of that, the TRL 4 to 6. How do you get that data in a relevant environment? And especially you want to do, especially microgravity or in the flight environments, How do you do that? Well, Flight Opportunity provide you, one of the speakers previously used the word cost-effective. I like that word, cost-effective platform to fly and test your experiment to get that feedback. So I just want to say, before I joined NASA 10 years ago, I spent 26 years in industry. And in the industry, spend late night writing proposals just to have some idea, hopefully get funded, and hopefully get built it to demonstrate my concept. So to all the PI that submit the flight opportunities, I get it. You know, you start out with an idea, you test out those ideas, and then as you gradually mature those ideas, you want to get to next step of testing to validate your idea or get feedback. So understand how valuable this is to you and how we're here to help you to pursue those goals. Next page. Okay, another way to look at it is the regime of flight opportunity is the first bar, and that is the suborbital realm of regime. Next bar is commercial and LEO space. There's a venture class and CRS and commercial crew program, space station. Next one, lunar exploration, eclipse program. So you think of the bar in terms of cost as logarithmic cost. It's an order of magnitude higher increase to take you to fly on those. So in the suborbital flight, you can do it for tens of K or even a couple hundred Ks to fly it. Okay, definitely less than $1 million if you have a full manifest. Where you go to commercial, go to LEO, you're talking securing a launch vehicle, it's hundreds of millions of dollars. So commercial suborbital offers a cost-effective solution to test your experiment in a relevant environment. That's the value of Flight Opportunity Program. So the lower, if you recall from your memory, there's lower TRL level program on the left-hand side, and as you go to midstream and go to higher live-out flight test program on the right-hand side. One opportunity for your experiment to not only fly on Flight Opportunity Program is try to get into STMD lower TRL level program, and that including SBIR, that including NIAC, STRG if you're academia, and once your idea get accepted and get vetted, and once ready, internally we can help you to go through a next step, which is the flight program. Oh, thank you. Yeah. So one question people ask, how do I get my idea flight tested? One way is if you're early at lower level TRL technology, seek out these early stage innovation program and try to get support on that. And then as the program grows, as your technology mature, we'll naturally find a way to shepherd you to a flight program. So this is my first time to ISPCS to Las Cruces, and I just looked at a US map. I couldn't help but wonder what amazing place this is. This is the test ground for all the flight testing. So what we have here in the Flight Opportunity Program in Spaceport, nearby Spaceport America, we have Virgin Galactic. That's going to be flight test out of here. You see George Whiteside talk about it earlier. Up Aerospace, who use solid rocket motor sounding rocket. Exos Aerospace, who were just flown about a couple months ago. Blue Origins nearby, near Van Horn, Texas. Worldview is in Tucson, Arizona. And Maston is obviously Mojave Air and Space. So this is a wonderful place for flight testing to come, the people to come. I would say the space cowboys. This is where rubber meets the road. So back in 2011, the Flight Opportunity first contract, by the way, so for the past 8-10 years, we tried different way of public-private partnership, including contractual mechanism. So we start with announcement of Flight Opportunity AFO contract mechanism, and in 2015 we shipped to Ready contract. So we still finding way to what work best with industry. And we look forward to that feedback from industry and academia, tell us what would be best for the next round of solicitation. So, but if you look at lower left-hand corner, made in space, fly with zero-G gravity of the 3D printing machine. Well, that machine is now in space station. They actually demonstrate additive manufacturing printing technology in space station. That's how they mature. Start with zero-G and then something else, and then eventually move to the orbital flight. And the middle, Mark Gibson, NASA Glenn, talk about heat pile limits in reduced gravity. Well, that's going to the kilo power program of the game-changing STMD division. And that's going to go to application to nuclear thermal rockets. On the right, Greg Zemelli, NASA Glenn, talk about radio frequency mass gauging. It started with zero-G flight. It progressed. Now it's waiting for a Falcon flight to go to a space station for long-term testing to get data for the propellant gauging techniques on space station. So things can grow. And 2012, we start out with Maston with a terrain navigation technology. It worked with Draper Lab as well as later on with JPL, you'll see. Well, that lander terrain navigation technology is going to grow. It's been slated for Mars 2020, lander technology. The first flight opportunity payload with up aerospace sounding rocket. It talked about one of the first experiment was FAA, the ADSB. Kevin Coleman talked about it. So we still continue supporting FAA and testing ADSB technology through high altitude balloon and also sounding rockets. And of course, the zero-G flight continue. By the way, there's a misconception people on zero-G flight because they see these pictures of people doing spin, people are having fun. They think it's just a joyride. But what you don't see is during the microgravity time, the time they take the design and test those experiments and the data they get feedback, it's what's valuable. So let me speed it up. Okay, 2013, the high altitude balloon near space. Again, start with the JPL with Maston. 2014, Maston. 2014 is a breaking point because we had payload with Virgin Galactic. And unfortunately, that's when a spaceship, one accident occurred, and that held us back. But now, it's 4 years later, 4.5 years later, we look forward to Virgin Galactic turnaround to start flying again. So it's an exciting time. So the message here is nothing goes as you plan, but you just gotta make adjustment, make pivot, and we just wait for the right time for them to get ready, and we'll get back on flying again. So again, 2015, we had pretty successful flight. Oh, up aerospace. This is when the GoPro camera go famous because you attach it on the payload section and you actually see the payload and rocket, solid rocket motor separation with the up aerospace rocket. And 2016 started with the Flight Opportunity Program was asked to take on additional tasks is to help small company develop small launcher technology for small launch vehicle for orbital launch vehicle. So we have through the ACO and tipping point mechanism, we have worked with several industry partners. In the rocket firing, you see is the vector space additive manufacture a liquid rocket engine injector by Marshall Spaceflight Center. And on the right with the airplane, it's the generation orbits gold launcher that fly on the G3 aircraft. I better speed this up. Okay, 2017, the Blue Origin flight, the first flight, and the Worldview high altitude balloon. And 2016, Blue Origin refly again. We see Virgin Galactic return to power flight testing and ready to accept payload. George won't let me tell you what time when they're gonna start going back to fly, and I just wink and say any time now. So it's a matter of weeks. So I hope I don't get in trouble with that. So what have we learned? So this path, this journey, in reality is a trial and error. In the beginning, we try to establish a market by being a smart buyer for the commercial sector. But we're happy to see last 8 years, commercial provider had developed and grown and mature and ready for a new tipping point. We learned who the user commercial suborbital flights are, and we learned the community, CSF and Next Generation Suborbital Research Conference. We gain confidence working together. We're still experimenting and refining the contractual mechanism. So again, the feedback is important. Today, we have enabled 122 flight with 93 payload. He said, wait a minute, how come number of payload less than number of flight? Because the same payload may flown twice or 3 times. So, but as a result, one of the things we find out is some of the people earlier starter in the commercial market, the vehicle provider, they don't make it because it's a commercial model. It's not relying on government funding to help you go through it. And for example, Armadillo, for example, but happy to say Armadillo being bought out by Exo, so there's a continuity on that one. But because the development difficulty that these companies encounter, so some of the payload we sign up with them, we still waiting to fly. We still have 62 additional payload waiting for flight. So just show you, it's not just number of payload we select, the more mission we sign on, but also it's a partnership. The flight provider has to be ready and had to overcome their developmental challenges as well. So again, we find public-private engagement is key. It's sometimes because a commercial model, as you know, we really cannot tell industry what to do, but we just wait for them to come figure their way around and work with us. And I usually tell the industry, we work with you when it's the right time, when it's above mutual interest, and strategically that is mutually benefits. So industry tell us is, hey, don't come look inside to our kimono, just be a good customer. So we had to respect that. Okay. So these are the companies that we work with through the in center, the NASA meatball, and the first round is the flight provider, and as you expand, these are the payload community that we work with. So we're happy to say other flight provider coming online. Exos, for example, is coming online and just flew a couple months ago. Raven, it's a high altitude balloon company. It's out in Sioux City, South Dakota. It just won our IDIQ contract, flight provider. And we're happy to say Virgin Galactic is back. So how is this a tipping point? So the key message here is we see that a lot of flight providers are ready to go on bigger and better things. So it's a significant step forward, and payload begin to fly from multiple providers. So we, in the Jim Bridenstine announcement of the Flight Opportunity Program, we're happy to say we enjoyed a funding bump, and therefore it implied we'll select more payload. And we're happy to say we'll try to select, you know how tech eval process, they have selectable and non-selectable proposal. We'll shoot for 100% that's classified selectables. Ready 19 solicitation released early in 2019, so be on the lookout for it. Encourage people to apply. And human tender flight suborbital. This is a hot topic right now as Blue Origin and Virgin Galactic is enabling human tender flight. So headquarters taking on this very seriously, undergoing study, and hopefully they come out with a policy decision by the end of this calendar year. And that's all I have. Thank you.
Thank you. Yeah. So I don't have a lot of questions for you, but I'm very interested in that last bullet that you had. What do you think it's going to take for the agency to sponsor human-tended suborbital experiments? I understand there's a policy going to come out, but you've been around for a while. What do you think it's going to take?
Well, I've been around for a while, but I don't understand the political decision-making process. So I'll beg to say, ask the next question.
Okay. I'm looking over here at our friends in the media. I'm trying my best to get you some good quotable quotes, and people are just, what can I say? They're too smart for me. Okay, well, let's go with the questions I got here. Good answer, Tim. Space debris is a huge challenge to space commercialization. We're talking low Earth orbit, I think. Is the NASA Flight Opportunities Office a logical arena for developing some mitigation strategies?
This is for orbital flight?
For orbital debris.
So I've confessed, I come from a small launch. I'm a launch vehicle guy. So in my heart of heart, I like to see flight opportunity help industry develop an orbital launch capability. But again, my boss says we will stop funding the small launch technology effort, be focused all on suborbital. So that's the marching order I got.
It's hard to do debris mitigation from a suborbital platform.
Yes.
Yeah. Okay, well, let's move right along. What kind of support, advice, or encouragement does the Flight Opportunities Office provide to faculty who are starting in their academic career to fly their research?
I say we look for quality proposals. The one is submit your proposal, do the best you can, and if you don't get chosen the first time, consider a challenge, try it again. And we will offer debriefing and consult you where your weaknesses are and where we'd like to see in the future. And so hopefully that could provide you some guidance for next round. And the history has shown us people have applied multiple times, and the first time they don't succeed, they apply again, and eventually they get it.
Okay. Last question I've got, was the Solstar Wi-Fi in space a Flight Opportunities project? I'm not familiar with it. Maybe you are.
Yeah, Solstar, Brian Barnett is in the room. It's a payload that was selected by Flight Opportunity, and he's selected just like everybody else. He submitted a proposal, and there's a technical review panel, and he was deemed selectable, so he was selected.
Very good.
Yeah.
Okay, and that's all I've got here.
Okay.
So thank you very much.
Thank you.
And thank you for being here.